let's go to page 349 and start with number 540. Okay, so number 540, you have a triangle with an altitude of h and base b, and it says the height is length by m, and how much must be taken from the corresponding base b, so that's going to minus the x, so that the area of the new triangle is half of that original. Okay, so the new triangle would be 1/2 base times the height, and half of the original would be 1/2 base times height. Okay, so from here the half cancel out, and since we're solving for x, we're not going to multiply out, okay, because x is already isolated. So I'm just going to divide by h plus m, divide by h plus m. So b minus x will equal to bh over 2h plus m. Okay, and then from here, I'm going to plus the x on both sides. So this will cancel out, and I'm going to minus this to this side. So I got b minus bh over 2h plus m equal to x. And what I'm going to do next is I'm going to flip this over and make it into common denominator. So make it x on this side. Now this one over here, make it into common denominator. Okay, you're going to get 2bh plus m minus bh over 2h plus m. Okay, so this came from making this common denominator. And then after that, go ahead and multiply everything out. So 2bh plus 2bm minus bh over 2 times h plus m. And so this one and this one can combine. So x will equal to 2bm plus bh over 2 times h plus m. And this one I can factor out the b. So it will be b times 2m plus h over 2 times h plus m. And that's it. Okay, let's go to the next one. Uh, 541. Okay, a company with 4 senior partners, so 4 seniors and 3 juniors. And they want to form a committee that have at least 2 seniors. So greater than or equal to 2 seniors. And at most means have to be less than or equal to 1 junior. So how many ways can you do this? Okay, so first let's go ahead and make the column. So start with, so you can have 2 0, right? 2 of these, none of these. You can have 2 1, and you can have 3 0. You can have 3 1. 4 0, 4 1. Okay, so let's go and figure out each case. Okay, so for this case, this would be, there are 4 of them, you're going to choose 2, so it would be 4C2. And this one you got 3, you choose none, so it would be 3C0. And so this will equal to 6 times, so you figure out this would be 6, and this would be a 1. So you can, the 0 factorial, when you evaluate 0 factorial is equal to 1. Okay. This one you're going to get 4C2. There are 4 of them, you're going to choose 2. Over here you got 3, you're going to choose 1. And so this will equal to 6 times 3 equal to 18. This one there are 4, you're going to choose 3. Oh. And this one you got 3, you choose 0. Okay, so this one you're going to get a 4 times 1, you're going to get 4. This one, there are 4, you're going to choose 3. This one you got 3, you're going to choose 1. So again, this one can give you 4, this will give you 3. So this gives you 12. This one, you're going to get 4 choosing 4. And this one you're going to get 3 choosing 0. So it will be a 1 times 1 equal to 1. Okay, this one over here you got 4C4. And this one 3C1. So this will be equal to 1 times 3 equal to 3. So you add all this together, you get 44. Okay, let's go to 542. Okay, equilateral triangle. With a side A. A new equilateral triangle is formed by joining the midpoint of each one. Now, if this is A, this is the midpoint, this would be A over 2, A over 2, and each of these would be A over 2. Okay. And since it's an equilateral triangle, so all these would be A over 2. And the third equilateral triangle is formed by joining the midpoint. Again, so join the midpoint. Okay, and then in that case it would be A over 4. And so forth, and goes on forever. Find the limit of the sum of the perimeter of all the triangles as drawn. Okay, so the first parameter is this one over here, equal to 3A. The second parameter is each side is A over 2, and there are 3 of them, so it would be 3A over 2. So it's going to be keep half, right? So P3 will be half of that again, so it would be 3A over 4, and so forth. Okay. So from here, so this, since it goes on forever, this is an infinite geometric series. So over here, R equal to 1/2. Okay. So infinite sum will equal to T1 over 1 minus R. So this will equal to T1 is your first, is the first term, so it will be 3A over 1 minus R is 1/2. Okay. So the total sum would be 3A over 1/2. So S will equal to 6A. Let's go to the next one. Okay, 543. Okay, you express the arithmetic mean of all the integers from -101 all the way to 100. So I'm going to write out a few of them. And you're going to have the 0, -1, 0, 1, dot, 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 99, 100. Okay, so you have all these numbers, all the way from -101 all the way to 100. Okay, to find the mean, you have to add all these numbers together. Okay? So notice if you add this, not counting this over here, okay, you add this will equal to 0, this will equal to 0, all it will equal to 0. So all this will pair up equal to 0. So only one you not pair up is this one. So the sum will be equal to -101. Okay. Now you have to divide by total numbers, right? So if you notice, if you divide by total numbers, you chop it up. So 1 through 100, there are 100 numbers. From -1 to -100 is 100 numbers. Okay, and that's 1 here, so there are a total of 202 numbers. So again, 1 through 100 is 100 numbers. -1 through -100 is 100 numbers, and you have the 0 and a -101. Okay, and so you simplify, so this will give you -1/2. So the average of all these numbers is -1/2. Okay, let's go to 544. Okay, from the sum of all whose numbers from 0 to 10 cannot be represented the total number of intersection of 5 distinct coplanars. So basically what you have is you have 5 lines, and you want to figure out what number of intersections cannot be represented. Okay, so let's go and do this. Okay, for the zero intersection, okay, all you have to do is you get all 5 lines parallel. 1, 2, 3, 4, 5. Okay. For the one intersection, you can have all 5 lines intersect in one point. Okay, so in this case, you get 1 point right over here. Okay. For the 2, okay, there's no way to get 2, and there's no way to get 3. If you try, it's not going to work. Okay. For the 4, all you have to do is just get 4 parallel lines, 1, 2, 3, 4, and 1 vertical line. Okay. So this will give you the 1, 2, 3, 4. Okay. Now for the 5. For the 5 intersections, what you want to do is you want to get 3 parallel lines and 2 intersection lines that is on this over here. So again, these are just some examples. Okay, so this way you get 5 intersections. Okay. Now let's go to 6. The 6 is kind of easy too. 6, you're going to get the 3 and 2. So you're going to get 1, 2, 3 parallel lines and 2 parallel lines going this way. Okay, so you're going to get 6. Okay, now for 7, we can get 2 parallel lines and 1 vertical lines, and then you can do this intersection this way. Okay, so you're going to get 1, 2, 3, 4, 5, 6, 7. Okay. Now for the 8, you can have this way: 1, 2 parallel lines going this way, 2 parallel lines going this way, and 1 that going this way intersecting all 4. Okay. So that way you get 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, for 9, it's going to be similar to that. So you got 2 lines going this way. Now, but instead of, see right now the 8, right, you got 2 lines going this way and 1 line going this way. For the 9, you have to do the other way. Okay, so you're going to have 1 line going this way and 2 lines going this way. Okay, so you're going to get 1 line going this way and 1 line going this way. Okay, so you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay. Now for 10, so notice there are less and less parallel lines. So number 10, I'm going to use a big space over here. So number 10, you're going to have all non-parallel lines. Okay, so you're going to have, so first line over here. So each succeeding, the following line would intersect all the other lines. So 1, 2, and then you have to do the 3. And then the 4, the fourth line have to intersect all 3 lines. And then the 5th line have to intersect all the other 4. So like this way. Okay. Okay, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay. So the sum of the number cannot represent would be 2 and 3. So you add this together, so the answer would be 5. Okay, so again, 2 and 3 are impossible, so the sum of those two numbers equal to 5. Okay, let's go to next one. Okay, so it's a radiator of an automobile already contains 6 quarts of 10% solution of antifreeze. How many quarts of pure antifreeze must be added to get 20% of antifreeze solution? Okay, so this is a very basic standard mixture problem. So go and make a table for the mixture problem. It helps you to organize data. Okay, so you have 10% solution. You want to mix with the pure, and you want to get 20% antifreeze solution. Okay, so this is the strength of the mixture. This is the amount of the pure amount, and this is the total. Okay, so 10%. So strength of the 10% would be 10. Strength of the pure antifreeze would be 100%, right? So it's 100. You get 20. Okay, and amount. So there's a 6 quarts of the 10%. And how many quarts so you're going to mix? That's what you need to figure out. So when you mix together, this would be x plus 6 amount for the mix. Okay. And then now all you have to do is go ahead and finish up the table. So you can just multiply. Okay. Again, I'm just kind of get rid of the percents. Okay. So there are 10% of the antifreeze times 6 quarts. So this is pure amount, the subtotal. So it would be 60, 100x, it would be 20x plus 120. Okay, so when you make these two together, you're going to get that. Okay, this is for the pure antifreeze only. So 60 plus 100x equal to 20x plus 120. Okay, so move things around. So you got 80x is equal to 60 divided by 80. So x equal to 3/4 quarts. Okay. Okay, let's go to 546. Okay, so if you use 999 digits to write page numbers consecutively start with 1, how many page number will you write? Okay, so page 1 through 9, this will use 9 digits. Okay, and so this is a single digit. And page 10 through 99, so this one will give you the number of pages would be 99 minus 9, right? Because start with 10, so you have to minus what is not there. So this will give you how many pages. And each page will use 2 digits, and so this will use up 180 digits. So let's go and figure out how many digits are left for the 3-digit pages. So 999 minus 9 minus 180, and this will give you 810 digits left. Okay, so 810 divided by 3 digits each for the 3-digit page. This will equal to 270. Okay, so there are 270 the 3-digit pages. Okay, so the total number of pages would be 9 for the single digit plus the 90 for the double digit plus the 270 for the triple digit, and this will equal to 369 pages.